Everybody, welcome back to the No Frills Web Animation Challenge. Here we have the final round 3 results. Let's go. First, a little recap. I built this series of challenges to get a sense of how modern tools can handle basic animation sequencing tasks. For challenge 1, we had just 2 elements coming across and then moving away vertically. Not too bad. For challenge 2, the client requested an initial fade and an expanding bar. Not too bad. But challenge 3 added a bounce and a spin. Although these changes may seem harmless, we will soon learn how devious our mystery client is. Join me as we explore a wide variety of solutions to this treacherous challenge. Alright, well here I have my challenge 2 finished file basically opened up, and you'll see we have our familiar animation of the 2 boxes meeting each other after things fade in, and then they pause, and then they move away. Alright, so we've been going through how to build this with a variety of technologies, but I'm going to now add the challenge 3 changes. First, have red and blue elements bounce off each other when they meet. Okay, well, here are the 2 animations where they come across on the x-axis. So what I'm going to do is just add an ease of bounce to this one right here. And I'll just do a copy and paste for the second one. And let me hit run. And you'll see that that change there took less than 30 seconds. So boom, we have the bounce, and now we're cool. The next one says, during the last second of vertical movement, spin red and blue 360 degrees with a slight overshoot. How are we going to do that? Well, these are the out animations where red and blue move along the y-axis. And what we're going to do is add an additional animation here, and we'll do a 2 tween. The target's going to be dot red and dot blue. And so what we need to do is rotate them 360 degrees. For that overshoot, we're going to use an ease of back. And so the slightly tricky part is that this needs to happen during the last second of vertical movement. So we're going to use a position parameter here to have this start 1 second before those other animations end. All right? And we'll also specify that the duration of this animation is 1 second. So let me run. And now, if we pay attention, you'll see, yeah, we have the fade in, the bar growing, the bounce, and then as they get up here, boom, everything's working perfectly. So there you have it, 2 changes in about 2 minutes. What I'm going to do is save this as challenge 3 finished, mission accomplished. We will turn on GSAP tools, we'll run one more time, and we'll ship it off to the client. They'll be able to see it in all its glory, speed it up, slow it down, scrub through, and just soak in all that subtle nuance they requested. Awesome. Now I know you're probably thinking, Carl, when do you need to bounce 2 boxes off each other or have something spin while it's moving up with a different ease? Well, I use these sort of crude examples to make it really clear what some of the issues are. So something like a bounce ease is going to be very difficult with CSS animations because your timing functions are controlled by just these 2 control handles here. You're never going to get the type of curve that you need for a real bounce using a single ease curve in CSS. And maybe you don't want to bounce, but maybe something like elastic where you need to overshoot a few times, or maybe a rough ease where you're going to make things shiver and shake. Again, very difficult using CSS, but easy with GSAP. And now to discuss having the rotation happen while something was moving off screen. If you study Google's material design docs, you're going to notice that there's a bit of a trend towards arced motion, okay? So right here we'll see that on the right, they have a little bit of an arc happening as this element expands, all right? It's not just linear. Scrolling on down the page, here's an example that we can actually scrub through, all right? You'll see that as this little guy in the lower right here grows, it's actually moving along an arced path while the scaling is taking place. So this really illustrates the importance of being able to independently control transforms on an element and also have precise control over the sequencing. So in a UI animation that may only last 300 milliseconds, there's still a lot of different properties being animated of different elements with very precise choreography. And again, that's where GSAP shines. So to get this arced motion, you might be thinking, well, how do I do that? arc motion can be achieved by using different eases for X and Y motion. Right now we have a linear ease for both the X and Y axis as this little ball travels from the lower left to the upper right. But if I apply a different ease to the Y-axis animation, let's do something like a power 4 in, whoa, there you go. We start bending its path of motion. On the X-axis, I can do something like a sine curve, and depending on which eases you choose, you're going to get some different results. Let me do a power 3 here, and that's going to shift it that way. So by doing different eases on different axes, you can control the curve and the speed. You know, I like something like a sine and sine in here, gives you a very nice gentle curve. Now, having something move off screen and then rotating it with a back ease may be an unpopular client request, but I did it because it was easy to visualize and I wanted to just enforce the importance of having this independent control over each transform value. So now that I've shown you how easy those changes were with GSAP and why these things are important, let's look at some of our other entries. Alrighty folks, Jay is back. When you take a guy who's disciplined enough to do a dozen muscle ups, you can rest assured he's not going to back down to a CSS challenge. So let's take a look at his animation. You'll see that it meets my client's demands perfectly. I like the bounce. What do we got? A little overshoot and a little snapback. Cool. All right, so let's look through the code, and before I do, I need to make it extremely clear that Jay knows that this isn't the best approach or the most practical, but knowing that this is so difficult with CSS, it's extremely impressive that he took it on and went the distance. Definitely watch the previous videos to see how he's been using scoped variables. For this one, he's creating a travel variable based on X and X0 variables that he's defined previously, all right, to sort of figure out how far we're going to move while we're bouncing. And so in here, we have some more calculations for the delay, but where it really gets interesting is down here. You're going to see that he added these pseudo elements to red and blue, okay? Because as I've pointed out, with CSS animations, you don't have independent control over transforms. So some people will choose to nest an element inside of another one, but the pseudo approach works just the same. So he might move the red element and then spin its pseudo elements of after here. So if we look at keyframes horizontal, this is where the bounce is coming in, making all these calculations here. So at 12%, he is calculating all these different scoped variables, and based on his travel variable, he's then multiplying by this coefficient here, which he admits that he sort of pulled out of Google Air, okay? So you'll see that for 24%, all these sort of magic numbers come in. So these are the different keyframes for the different parts of the bounce, all right? Probably a little tricky for the average Joe to hand code, but I was very impressed with the end results. For the spin here, you'll see at 95%, he's over rotating to 405 degrees and then bringing it back to 360. So one last time, we'll take this for a spin just to show you that he did accomplish it perfectly. And again, it's probably not the approach you would take on a real job, but he stepped up to the impossible challenge and proved it's possible. Awesome work, Jay. All right, next we have an example from the keyframers. All right, these guys came back with both guns blazing. Let's run their example and we'll see that they have a very bouncy bounce. Cool. And everything works as I specified, all right? So they got the job done. Now, let's see their approach. They took a very interesting approach using mix-ins. Now, they went all the way back to 1700 BC for this Babylonian approach to figuring out square roots. And then scrolling on down, they have this mix-in for insert bounces. Now, I'm going to very quickly get out of my league talking about this advanced stuff because, quite frankly, I don't know it all. But in their live stream, they walked through their approach, they showed how it worked, they explained why they did it, and they did an awesome job. So you have to watch the Keyframers episode where they take on Challenge 3. Now, all this code here is going to be used to dynamically output the bounce keyframes that they need. So let me scroll on down. And here I'm getting into their code of where things are going to be happening. And we've gone through this in previous episodes. And again, they explain it perfectly what all of it means. But I want to show you right here. Keyframes red 1. And you'll see that we have this include statement here, insert bounces, and it's going to be passing in some parameters to create the bounce, and the mixin function is basically going to spit back the necessary keyframe. So we have the same thing for red 1 and blue 1. They're using the same approach there, okay? So what I'm going to do is go to our little handy tab here, and we'll do view compiled CSS. Now if I scroll on down to where are we? Oh, here we go. We're in it right now. Let's go to keyframes, red 1. Where are you? Okay, so red 1. So when that mixin gets compiled, it's going to output these keyframes here. So we have all these percent values that, as a human, you'd never be able to create yourself. Now you may be looking at this and being like, I can't read that code. Why'd they need that mixin function? And Shashaw made a point that, whether you're using GSAP or something else, you're going to need an equation to generate the bounce for you. So they're using an equation that was created with a CSS mixin. So yes, it's a lot of code, but it's also sort of computer generated, all right? They didn't have to hand write all of it. So they made use of the tools that they have. And again, they got a very cool bounce that can be configured, all right? So awesome job on that. Now to handle the rotation when the boxes move away, they took a different approach than Jay. So let's just watch one more time, and you'll see that when the boxes bounce, they move up and then they spin. So I mentioned that, with CSS animations, you can't do multiple transforms with different values or whatever independently. So what they did is that they created a wrapper element around the box. I told Shaw that semantic purists would frown at this, but that was all in good fun, all right? For something like this, it's perfectly fine. And really, I have to give them a ton of credit for not only doing this challenge, but doing it live and in a reasonable amount of time, all right? So definitely watch their video, check it out. David will explain this stuff much better than I will, and I suspect you'll be able to use this bounce mixin someday in your own projects. So follow the keyframers, watch their live streams, and you're going to learn a ton. All right, folks, we have a surprise entry from Aaron Sherrill, aka Motion Harvest, and it took me 3 challenges and countless code reviews to realize that this layout in CodePen makes a lot more sense for this, all right? So on the left, you'll see our animation that Aaron did, and it is perfect. How'd he do it? Well, he did keyframes, and you're going to see there's quite a bit of keyframe information here, and he's just so precise and smart that he knows where to set things at 72%, 0.067039, blah, blah, blah. And he doesn't care about individual translations and rotations. He's going to smash everything into a matrix here, okay? So what he's done is he's bypassed that whole thing about how we can't set individual transforms, because when he's using a transform matrix like this, all the transform information gets slammed into one value. And this guy is a genius. Look at how he figured all this out on his own. How did he do it? I'll tell you in a second, but first, he went ahead and did challenge 3B. He took the client's request and went a mile further. Look at this fun animation. Look at the great physics and the great realism that he has. It's awesome, it's playful, and you'll lose your mind trying to read the CSS. So, how is he so smart that he can write in all of this information, get this precise timing? The answer is that he's created his own animation builder, all right? The code is available on GitHub. An animation builder is basically a tool that plugs into Adobe Animate and lets you export CSS keyframes. So awesome job, Aaron. I gotta say, I was not expecting this solution. Love it. Now I know some people are saying, when will I ever need 2 boxes to bounce off each other and then move away and spin at different times? Well, here we have a little example where we've taken those same techniques and made them look a little bit nicer and perhaps a little bit more real world, all right? That example was always meant to be abstract and no frills to make the contest easy. But here you'll see that if you take a look at those hands, you'll see they're moving on an arced path, all right? And that's achieved with that technique I showed you about applying different eases to the X and Y values. Again, reinforcing the fact that there are times when you need those independent transform controls. And it's very obvious too that these words here are bouncing off each other. So imagine a client had these types of requests. I don't think they're too far-fetched. They may even like the effect so much that they want it to be used in various panels of an animation to build a full-blown ad like this. And once you have an animation like this in place, obviously you'll want them all to happen in sequence. So you'd probably move on to something like this, where each panel animates in sequence, all right? You have that cool bounce effect, multiple icons, and you have this cool sequence going on. Now, once you've put in all this work, imagine now that the client says, I don't like that bounce. Well, you can just change one variable and make this something like a power 2, ease out, and then when you run, all those changes trickle down to each part of the animation, and you're not killing yourself and pulling your hair out. Similarly, you may want to adjust the amount of time between when each panel comes in and goes out. If you watch real close, you'll see that the first panel goes all the way out before the next panel comes in. If I change a little variable up here and do like a negative offset, like 0.5, you're going to get a really cool overlap effect. So new panels are coming in while the previous panel moves out. Let me just grab my scrubber bar there, and you'll see that when wash hands comes out, wear a mask is coming back in, all right? So changes like that, once you've built your animation, are real simple if you build it the right way. All right, thanks so much for watching. That wraps it up. I really enjoyed this challenge. I learned so much from a bunch of people. I set out saying, I wasn't gonna make fun of other technologies, and in summary, all I'm gonna say is that I haven't yet been persuaded to use something other than GreenSock for the type of web animation that I do, all right? I know people like their tools for different things, and that's all good. I wanna give a special extra thanks to the keyframers for taking on this challenge. I know you guys are equally as passionate about CSS animations as I am about GreenSock, and I was setting up some traps. You knew I was gonna make it difficult, but you took it on gracefully and respectfully, and you showed us some awesome work, and I was definitely impressed, all right? I thought this stuff was gonna be pretty much impossible, but you did it, so awesome. And I hope people who are watching will subscribe to the Keyframers and learn more and more from them. So thank you so much again. Also, big thanks to everybody else who's been following along, participating, and especially sharing on social media. Jay, you were awesome. Mamboliu, Louie, loved your work. We got Zim Learn, who's Dr. Abstract, Motion Harvest, GreenSock, and a big thanks to my Creative Coding Club members who have been supporting me along the way. I couldn't do this without you, so thanks so much. I'm gonna go shave. Oh, I did say part of this challenge was to advertise my courses, so if you want to learn more from me about GreenSock, join creativecodingclub.com today. You'll get access to all my courses, exclusive demos, and fun stuff. Join now for one low monthly price. See ya!